Good morning, everyone. My name is Greg Aranda with Graybar. I'd like to welcome you to Graybar's G2 Talk presentation this morning called What You Need to Know About LED Tubes and Plugins. This talk is part of our webinar series that we offer each month for our customers. We have a great discussion lined up for you today, but before we get started, I would like to cover a few housekeeping items. First of all, if you are one of the first 50 people to join the presentation this morning, you'll receive a coupon for a free cup of coffee, courtesy of Graybar, as a thank you for your time today. Also, at the bottom of your screen, you'll see a box for questions and answers. Feel free to submit questions throughout the presentation, and we'll address as many as possible at the end. Lastly, our G2 talks are all archived on graybar.com. You'll be able to view this presentation again or recommend it to others. We're happy to team up today with GE Lighting. As a full-service distributor and energy product specialist, Graybar works alongside GE to provide the latest lighting technology to help provide significant energy savings and ease of installation. You can visit graybar.com to learn more about our solutions. I'm happy to introduce today's speaker, Mary Beth Gotti. Mary Beth is the manager of the GE Lighting Institute in Cleveland, Ohio, and has worked for GE for more than 35 years. Her positions have ranged from lamp development engineer and scientist for both incandescent and metal halide lamps to senior lighting application specialist at the Institute. She has a master's degree in physics and an MBA from John Carroll University in Cleveland, Ohio. She also has a lighting certified credential from the National Council on Qualifications for Lighting Professions. Mary Beth is active in the Illuminating Engineering Society and currently serves on the Executive Committee of the National Lighting Bureau. So without further delay, I'd like to turn it over to Mary Beth. Take it away, Mary Beth.
Well, thank you very much, and welcome everybody to this webinar. And we're always excited to talk to you about lighting, and especially with LED solutions today. And you think about, the formats, and whether you want to do simple replacement lamps, take out one light source and put in another, or go to kits or new fixtures. There's just a whole array of solutions today that can get you into the LED age and be part of this lighting revolution. So recap just a few things, if I can, about where are LEDs today and why are they driving such interest. And many of you are already involved with LED types of solutions, but really the lure of just really higher and higher energy efficiencies. And LEDs aren't done yet. I mean, next year you'll have even more efficient solutions than this year. So we haven't plateaued yet in the performance of LED systems, in contrast to non-LED solutions, or legacy products as we call them, which have evolved over the past 50, 60, or 70 years. And fluorescent is still a very viable solution for commercial and institutional ceilings, but as you can see, LEDs are surpassing them in performance and have a lot of other great practical attributes which make them such a tempting solution for so many of our applications. If technology is helping drive technology change and providing, what's possible today with lighting systems, energy legislation is driving change. And again, as many of you know, there's so many light sources that have been near and dear to our hearts that we can't get anymore. Whether it's some of the standard incandescent light bulbs for our home, to T12 fluorescents, even some of the earlier T8 linear fluorescent designs or older designs that have been hit by lighting legislation. But the good news is there's much better products to put in their place, and LEDs are clearly into the mix right now. So as we think about, let's look at retrofits for T12s, and I can't see you raise your hands over the phone or necessarily over the webcast here, but there's probably still a couple 100 million T12s out there, and finding some alternate solutions for them is important, because you're not going to be able to buy these common T12 watt misers, or if you do, there are specialty lamps that are significantly more expensive, and by the way, they're energy hogs. And we've gone from T12 to T8 solutions in those fixtures for, boy, more than 20 years at this point. So getting your 50% energy savings or approximately is very common. Retrofit kits where you can change the look of the fixture and update it. And now LED tubes are clearly into this mix. So whether it's LED tubes, LED kits, or LED fixtures, there are some great opportunities to jump from T12 fluorescents or even TA fluorescents into the world of LED today. So why would you pick LEDs versus fluorescent? Well, current efficiency levels are exceeding fluorescent. It hasn't been that long ago when I used to say, wow, LEDs and fluorescent are neck and neck. Well, LEDs continue to surpass fluorescent and get even better. 50,000 hours life without interim failures, and this is a big deal for cost of ownership. Fluorescent systems today can last 80,000 hours or more, but you expect half the lamps to have failed by 80,000 hours. That's how we define average rated life of non-LED solutions. And in the case of LEDs, they get dimmer over time, but we don't really expect them to fail. So again, that affects your cost as you don't have to necessarily relamp failed lamps and the labor that it takes to do that. LEDs have great optical control, really being able to get light where you need it. In the case of some of these retrofits, really making fixtures more efficient, really not depending on so many parts of the fixture to deliver light down into my space. The fact that LEDs have no lead, no mercury, we really don't know how to make mercury-free fluorescent lamps, so, not having to think about recycling products because of any elements that could be potentially harmful to the environment. The durability, instant-on, dimmable, full light output, being able to operate on any on-off cycle, virtually no infrared or ultraviolet in the output, it really is leading to this digitization of lighting. So really a lot of great attributes. Why pick LED tubes and plug-ins versus retrofit kits or new fixtures? And, it's easy. It's just a very convenient way. It's a simple conversion to LEDs. We can use a retrofit model that is familiar. I mean, GE's been watt-misering lamps since the beginning of light, I think. And, whether you're going to a more energy-efficient tube retrofit or going and changing out the fluorescent ballast and the lamp and retrofitting to LED tubes and a separate driver, again, it's a model that we're very comfortable with and that has been very successful for so many years. And, if you have fixtures that still look fine and fit the application, no real reason necessarily to maybe take out the fixture. Or maybe you don't want to interrupt the ceiling, right? So being able to retrofit with tubes and or separate drivers really is a very attractive value proposition. Okay, so let's get into some of the specific for these what we call LED refit solutions. And again, we're going to focus primarily on linear fluorescent replacements, but we'll also cover a little bit about plug-in LED replacements for CFLs. Okay, as a recap, and this may be review for some of you, but there are a lot of different LED tubes out there, and when you think of main categories, which really gets at the functionality of these tubes, there's UL type A, UL type B, and UL type C. So, how you retrofit them into a fixture changes. Do you have to rewire a fixture, or am I just changing out one fluorescent tube and putting in an LED tube? So just looking at this brief summary, but UL type A, you got a LED tube with an integrated driver. So driver is electronics that converts AC to DC and operates your LED arrays. That works on existing linear fluorescent ballast. Does it work on all linear fluorescent ballasts? No. We'll get in a little bit more detail about that. UL type B, this is now where you're going to take the mains voltage, whether it's 120, 240, 277 volts, and you're going to apply it to the sockets. So putting mains voltage to your socket and then putting in an LED tube that has some integrated electronics or driver in the tube. And then finally, UL Type C, where, again, you're going to take out the fluorescent ballast, you're going to put in an LED driver right in the same spot, essentially, and then put in tubes that just have the LEDs. So, let's look at the advantages and disadvantages. I'm going to start with UL Type B because, frankly, this is where GE is not going. We're not offering UL Type B products. You have to rewire the fixture. Again, I'm going to put my mains voltage to my sockets. So you have some rewiring, good system compatibility between the LED tube and driver, but we have some safety concerns. I mean, putting high voltage to those sockets, you really should change the sockets out. I mean, in order to maintain UL, there are some socket manufacturers that have said they're not going to really warrant their performance if you use this type of high voltage to those sockets. Putting stickers on to identify the fixture as being modified. So dealing with high voltage to the sockets, again, we're not going to go there. There have been some issues potentially with shock hazards, if you will, and the question always comes up, well, what if they don't put the sticker on, and what if somebody puts a fluorescent tube into that fixture that now has main voltage going to the tombstones? And frankly, fluorescent lamp will probably start at 277 volts. It just won't be on for very long. It's not going to like the very high currents that you're quickly going to exceed. So UL Type B, we're not going there. We're not offering those products. So we're going to go right to UL Type A and start talking about the features of that particular category, and then UL Type C. Okay, UL Type A. So again, I got LED tubes. I got a driver that's contained within that tube, and it's going to wire to existing linear fluorescent ballast. You can't get any easier than that, right? Take out a fluorescent tube, put in an LED tube. So when you think about it, though, so what's the performance of my system really contingent upon? It's contingent upon my linear fluorescent ballast. So we'll think about when does it maybe make sense to do that, and when maybe you should think about replacing the fluorescent ballast. So life is dependent not just on the LED tube, but the linear fluorescent ballast. So the older that fluorescent ballast is, you maybe think about doing something differently there. Compatibility also between the LEDs and the driver with the existing linear fluorescent ballast. So doing testing and looking at compatibility lists. So it may or may not work on your existing system, and we help you make the best decision there. Okay, so looking at our UL Type A LED tubes, they are designed to operate on T8 electronic instant start and programmed rapid start ballasts. Originally the thought was, gosh, maybe we should have them work on T12 magnetic ballast too. But, so we're not going there. These are designed to work on T8 electronic ballast, both instant start and programmed rapid start. These particular lamps do not require you to change out the sockets. You don't have to go to non-shunted sockets. If you're not familiar with that, if you, for example, converted from T12 to T8, systems, the instant start ballast for the T8 required you to shunt the socket, so you don't have to worry about that. This will work just fine. These particular tubes will vary in watts and light output depending on the ballast factor of your fluorescent ballast. So if you have a low ballast factor, a normal ballast factor, a high ballast factor, the watts and light output of this tube will vary in response to that different ballast factor, okay? We're over 100 lumens per watt, 50,000 hours, L70, and again, if you're not familiar with that rating, L70 means 70% of the initial light output is still there at 50,000 hours. So they're lumen maintenance ratings. L ratings are lumen maintenance ratings. They come in popular color temperatures, so 3,500 kelvins, 4,000 kelvins, 5,000 kelvins, good color rendering, dimmable. DLC listed, DLC is Design Lights Consortium listed. That's a certification by a third party, which typically is required if you're going to look for utility rebates on these products. UL approved, which is certainly important. And the tubes are plastic, and they're NSF rated for food applications, which again is important for that category. I put together some numbers. These are very rough numbers now. I mean, how many different fixtures are out there? How many different fluorescent ballasts are out there? Different designs here. We're just trying to get some idea of wattage comparisons. If you have a 2x4 fixture with F28T8, so that's been one of the most popular retrofits for existing T12 Wattmizer type systems. So, you know, again, I'm looking at approximate initial fixture lumens now, okay? 92 watts, maybe 7,000 lumens. If you're going to replace 4 fluorescent tubes with 4 LED tubes, lower watts, even more light output. You have the opportunity perhaps to delamp. If you want to go to 3 tubes or 2 tubes, is that a reasonable thing to do? You know, some spaces are overlit. We're never going to tell you to go lower in light level than is recommended for any given application, but we know that for, you know, designs that were perhaps more than 10 years old, that we may have more light there than what the current recommendations are for light levels. And of course, why waste energy? You want the right amount of light, and let's optimize our energy savings. So if you can go from 4 lamp to 2 lamp, maybe 50% energy savings, and of course less energy savings depending on how many tubes you actually put into the system. So energy is a big deal, but you know, again, reduce maintenance costs, being able to install LED tubes and not have to worry about them with interim failures like you do with a fluorescent system. I wanted to go just through, again, you start thinking about how much light comes out of these tubes, and I don't want to dwell on this too long, but you know, you look at catalog ratings for things like fluorescent lamps, and again, these are industry standard. This is you know, not specific to one manufacturer. This is how it's done. You know, there's guidelines and recommendation, how you measure light output from fluorescent tubes, for example, in photometric conditions here. But you know, F28T8 is, you know, maybe what, almost 2,700 lumens. Okay, how many lumens do I really need out of an LED tube? You operate a fluorescent lamp on different ballasts, so you multiply those lumens by a ballast factor. A normal ballast factor, that factor is 0.87 or 0.88. So that catalog lumen rating goes down to maybe 23, 25 in the real world. Not all the light comes out of a fixture when you put a fluorescent tube in a fixture, so you drop light output a little bit more. You got ambient temperature effects with fluorescent. That will drop light a little bit more. Some ballast, when you put these energy-saving lamps on, the ballast factor goes down. So, you know, you just read to the bottom line. If you want to replace a fluorescent tube with an LED tube, at least let's say an F28 fluorescent tube with an LED, you need probably somewhere around, you know, 1,850, 1,900 lumens. And the ones we're talking about are more like 2,100 or 2,200 lumens. So the bottom line is you're going to typically get even more effective light out of an LED tube for similar watts. Okay, so type A, take out a fluorescent tube, put in an LED tube, works on existing fluorescent ballasts. You got to check for ballast compatibility. Again, GE's got lists, trying it, making sure they light up properly, all important part of that equation. UL type C. Now we're going to put in an LED driver. So take out the fluorescent ballast, put in an LED driver. So some rewiring, but you know, similar in labor and processing and going from a T12 to a T8 fluorescent. So this, you know, especially moving forward, you're going to see even higher system efficiency, system efficacy, how much light per watt you're getting out, the biggest range of controllability, best compatibility between the LED tube and driver. You're back to low voltage connection to the socket, so you don't have to worry about shock hazards. So you're thinking long term. How can I just make sure? I want to retrofit the LEDs, putting in a new driver and the tubes that go with it. Just takes out any of the guesswork. Don't have to worry about compatibility lists, right? So, you know, what kind of systems are out there? There you have a picture. There's your LED tube. There is the remote driver that's installed in the fixture. You now have drivers that can operate up to 4, you know, LED tubes, drivers that are dimming drivers or non-dimming drivers. Just some typical system watts with the driver. So it's about 21 watts per tube, including the driver watts, which you have to include with that. Again, we're over 100 lumens per watt. Honestly, you're going to probably see numbers that are more like 120 or 130 lumens per watt soon. 50,000 hours L70, you know, all the popular color temperatures. UL approved, DLC listed, so again, suitable for utility rebates. You're also going to start seeing glass and plastic construction. You know, you have a choice. So you have plastic, which is going to be shatterproof, if you will. Glass allows us to get a broader distribution of light. So any of you have seen LED tubes, you know, the light basically comes out, you know, the bottom surface of the lamp in a fixture, and 160 degrees works quite well in a lot of applications. For some, you really want a broader angular distribution of light. With glass, we can accomplish that. We don't have to push the LEDs quite as hard to get the transmission through glass versus plastic. So again, stay tuned and look for that differentiation. And glass is certainly very rugged and very durable over long-term operation. A lot of history with glass tubes, right, with fluorescent lamps. Okay, so and start looking at these numbers now. Now I've included in my comparison cool white watt misers, your F34 T12s. If you have T12 systems going to the Type A we talked about before, it can't work because that LED Type A tube doesn't work on the T12 ballast. So now I'm kind of taking out the ballast. So that's why I said that the cool white watt miser, get a 2x4 with 4 lamps, is 148 watts, a real energy hog. There's a conversion to an F28 T8. Here I'm just looking at normal ballast factor ballast. You can even drop the wattage of the F28 even lower than that, which again is very common, but just for simplicity I stuck with normal ballast factor. So there's a similar fixture lumens. I can go to 4 LED tubes. Notice that so the watts are going down, but even more light than I had before. And then looking at the opportunity to delamp, going from perhaps a 4-lamp to a 2-lamp or even a 3-lamp system. So, you know, the bottom line is you can go to LED tubes and get some very, very nice energy savings, 40, 50, 60, even 70%, depending on the light output that's required for that application. A little more about UL. The products, the GE products I've talked about, the Type A and the Type C. I mean, if you have a UL approved fixture, you will maintain the UL approval for that fixture by going to these particular products. So if you retrofit an existing fixture that's UL approved with a UL approved LED tube, the fixture will remain UL approved, right? Okay, so what are my criteria? Should I go to Type A, which has got so much allure because it's really easy, or do I want to go to UL Type C LED tube? So if you've got an existing T12 fluorescent system, you got to go to Type C. Type A's aren't going to work. If you have older T8 ballasts, what do I mean by that? I mean, typical ballast electronic ballast warranties are 5 years. They're going to last more than 5 years. We know that. But you know, if you have fixtures that are more than 5 years old, I mean, are they 7, 8, 9 years old? I mean, maybe you should think about replacing the ballast with the LED driver and going to Type C. Maybe you have a ballast that it's just not compatible with these LED tubes. Of course, then your option to convert to LEDs to go to a Type C. If you have newer compatible T8 ballasts, you can go either way, right? If you need a optimum controls capability, again, we would recommend going to Type C. What about LED replacements for compact fluorescents? Again, this isn't really driven by legislation. There are performance limitations of compact fluorescent lamps, and let's really focus on downlights right now. And one of the big ones is that you don't get full light output. You flip the switch and you kind of got to wait a minute or so in order to get full light output. I can go to LED plug-in replacements and really get better delivered lumens from the fixture. Okay, so higher system efficiencies, if you will. And of course, longer life. If I could get my 50,000 hours, that would be a nice reduced maintenance cost. So a plug-in retrofit LED lamps. Again, simple conversions going from compact fluorescents to LED here. What would the numbers look like? First of all, we're going to focus on 4-pin lamps, okay? Specifically 26 watt, maybe even 32 watt, you know, again, depending on how much light you really need. So let's focus on the 26 watt. I got a downlight with a single tube installed vertically in that fixture. With the ballast, it's more like 30 watts, okay? I can go to a 12-watt LED, and I'm going to have an integral reflector. So again, I'm going to kind of take the efficiency of the fixture out of it at this point. That total wattage for that vertical LED CFL replacement is about 14 watts. A very common downlight has the two horizontal plug-in CFLs. So two 26-watt CFLs in that application with the ballast watts is more like 60 watts or so. I can go to these two horizontal plug-in LED lamps, and the system watts will go down to maybe 28 watts. So you're talking more than 50% energy savings here. Now, these are designed to work on the existing ballast in the fixture. So I'm not taking out the compact fluorescent ballast. I'm just taking out the CFLs and putting in these LED replacements. Okay? So, operate on existing CFL ballasts designed for those specific 4-pin, the G24Q and the GX24 bases. So these are 12-watt replacements for 26-watt or even 32-watt CFLs. They're 50,000 hours L70, so that's about 2.5 times the life of a common compact fluorescent. A range of color temperatures from the very warm 2700 Kelvin up to 4000 Kelvin. These are about 1,000 lumens a piece. They are Energy Star and, of course, UL recognized. Okay, so key takeaways. LED tubes provide convenient retrofits for many existing fluorescent applications. The convenience of a long life product that doesn't need to be recycled, that can provide very effective distributions of light. And again, these are high quality light sources here. I mean, you're not going to see dots or what we call pixelation. So you install these fluorescent tubes in a fixture, they're going to have a nice diffuse look. And frankly, in a lot of cases, they look even brighter than the fluorescent lamps. And part of the reason is we're pushing the lumens downward. You think of a fluorescent tube, which is emitting light 360 degrees around. Here, we're really taking the light and focusing it downward into the space below. UL type A tubes are very convenient. Can't get more convenient than just simply replacing a lamp, but you got to make sure that you've got a ballast that's compatible with the operation of these UL type A tubes, which have the driver integrated right within the tube. Dimming is a bit limited, and again, the life of the system is going to depend on the fluorescent ballast. What if the fluorescent ballast fails? Well, you got to put in another fluorescent ballast, okay? UL type C, you get rid of any compatibility issues because I'm matching up a driver and LEDs that I know work together. So again, very classic retrofit process and installation that ultimately is going to provide the highest efficiencies and full dimming capability and overall best performance. But it is a rewiring of the fixture. And then finally, LED plug-in retrofits for CFLs are yet another way to go LED. In downlights particularly, you're going to get more than 50% energy savings, 2.5 times the life, and being able to get to full brightness without waiting. That's all I have as a prepared presentation, but I'll be happy to entertain any questions at this time. So are there any questions in the queue, or if we can see if there's any questions in the queue, please?
Yeah, thank you, Mary Beth. That was a great presentation. Really appreciate the time. Yeah, we've got a lot of questions in the QA box. Reminder for everyone on the call: if you do have a question, feel free to type it in, and we'll try to get to it as soon as possible. So, Mary Beth, if you're ready, I've got some here. Can the
okay,
tubes
don't
run
give
off
me any hard. No, I'm just teasing.
Gotcha. Yeah. Can the tubes run off a T12 magnetic ballast?
The Type A tubes cannot run off a T12 magnetic ballast.
Okay. Which system is best for dimming?
The Type C will give you the fullest dimming capabilities. I mean, you essentially can buy dimming drivers mated up to the LEDs in that tube. The Type A is maybe a bit more hit and miss.
Okay. Here's one here. Why is it necessary to keep UL?
UL is, UL, when you think UL, you think safety. So you as a manufacturer and as a person who's purchasing a lighting system, looking for some indicator, and UL has been a very popular one, that you're meeting safety standards for your installation is very important for not only your peace of mind, but for insurance reasons and other potential liabilities.
What other links are you designing, and what's the timing on that?
What other, I'm sorry, what?
Links, like the size of the tubes?
Oh, lengths. I'm sorry. It sounded like links. Okay. Right now, 4 foot is obviously one of the most common sizes. 2 foot, 3 foot, and U-bend lamps are either here or coming soon, a little later this year.
And then, do you have a 2-pin CFL replacement?
Not at this time, no.
Here's one. Are they all DLC?
They are DLC, correct. The tubes are DLC listed, yes. It's Energy Star for the plugins. Where Energy Star leaves off, DLC certification takes over.
What improvements are you expecting by 2016?
I'm trying to get through 2015 here, right? But typically, what happens with the tubes, you'll see life extensions. GE is very conservative with their life rating, so perhaps longer life beyond 50,000 hours. I think, especially with the Type C tubes, looking for some significant lumen per watt improvements. High lumen type products where you can get up to your 120, 130 lumens per watt.
Okay. I want to remind everyone on the call, if you want to receive a little bit more information about these tubes or to get a quote request from Graybar, you can just type in tube, T-U-B-E, into the Q&A box, and we will route you to a local sales rep to help you out there. Here's another one that just came in. Will you have a system warranty for LED tube and ballast?
That is a great question. I assume that we would have, again, drivers typically are 5-year warranty. I haven't seen a specific warranty to cover lamp tube combination, but I would assume the answer to that is yes. Yeah.
Will your Type A ever be 100% compatible?
100% compatible? No. You think about, here's the problem. If you look at compatibility with major designs, major manufacturer, major brands, but how many different ballasts are out there? I mean, and there's some perhaps no name ballasts without getting into specifics, but I mean, that 100% compatibility is a dream and it's a goal. Certainly, I don't think we're going to ever bother with compatibility with, let's say, T12 magnetic ballast. I mean, it's a dying breed, so why go there? What's the cost benefit of doing something that's already becoming obsolete, right?
Sure. So what is the best solution and why?
Best solution of anything we've talked about?
Yeah, I'm guessing the Type A versus C or...
Yeah, and this is where looking at individual situations, individual applications, and the answer is it depends. I mean, you've got a newer T8 installation there. We're going from T8s to LED tubes is a simple way to go to LED. And honestly, going to LED is so popular. People just love the idea of going to LED types of solutions, whether it's mercury content, whether it's just the crispness and the look of the lighting here. Where do you get the best performance? I mean, Type C. I mean, I don't have to worry about this obsolete, not obsolete, but this unknown factor. Anytime you talk about compatibilities, I mean, I've got I have electronics in my tube, I got electronics in my ballast, and they have to kind of work together. So that's never 100%. You can design to try to have robust designs, but with Type C, I don't have to worry about it, right? So ease of installation, convenience, versus retrofitting, and the age of your system has got to have a lot to do with that.
Sure. All right, Mary Beth, we are about out of time. We still have some questions in the queue. We'll follow up with those individually. So thank you, everybody, for your questions. Mary Beth, thanks for your time today. It was a great presentation. Reminder to everybody else. Great. And reminder to everyone on the call, this will be archived. This presentation will be archived, so you can always go to graybar.com and view it again later. Another reminder, if you want to get a quote request on these lamps, just type tube, T-U-B-E, into the Q&A, and we will route you to a sales rep in your location. And that's all we have for you today, so appreciate your time, and hope you guys will join us next time on the next G2 Talk. Thanks again.